Hey guys, Alg here. I am going to work through this Chapter 9 practice test. It's the first part of Chapter 9, and I will post this up on our Google Classroom page or YouTube. So I'll just get started here and make sure you ask me if you have any questions on it. And if I make a mistake, make sure you point that out because I don't have an answer key right in front of me here. So the first one, this is a greatest common factor. Both of these terms have a 3 involved, so we can pull a 3 out of the expression, and we're left with 4x plus 1. And any of these kind of problems, if you multiply afterwards, you should get that. 3 times 4x is 12x, 3 times 1 is 3. Question number 2, they don't have a number value where we have a greatest common factor. 2 and 3 are both prime, but they do have an x. So we can pull an x out of that, and we're left with 2x to the second. X times 2x to the second is 2x to the third. And we'll pull the x out of 3x, and we're left with just 3. All right, question number 3. This is our kind of standard quadratic expression, and it's going to be a plus and a plus, so I know it's going to be a plus and a plus. I want to think of two numbers that multiply and give me 5 and add up to 6. So the only numbers that multiply and give me 5 are 5 and 1. So with what we call a equals 1, where the number in front of the x squared is a 1, then all we have to do is find two numbers that multiply to the last term and add up to the middle term. So if you FOILed this out and multiplied it out, you're going to get x squared plus 1x plus 5x, which is going to give us the 6x, and then 5 plus 1. All right, this one we have two numbers that multiply and give us negative 44, and add up to negative 7. So you think of the terms at 44 and 1, 22 and 2, 11 and 4. 11 and 4, if we used a negative 11 and a positive 4, negative 11 and positive 4, it's going to multiply and give us negative 44 and add up to negative 7. So we're going to get x minus 11 and x plus 4. And I know sometimes it's kind of sloppy writing, but keep in mind I'm writing with my mouse here. Okay, now here's our little bit harder type of factoring for 5 and 6, where we have where the first term number is not 1. So we're using the box method, and in some ways it's kind of that same idea where you have two numbers that multiply, but not multiply for the last term. It's multiply and give you 3 times a negative 5. So multiply and give us a negative 15, and add up and give us negative 2. So what we're going to do is rewrite that middle term, negative 2x, with negative 5 and positive 3. Think of the terms that multiply and give you 15. There's not that many. There's 15 and 1 and 5 and 3. And if we have the negative 5, positive 3, that'll be a negative 2x. And now what we want to do is we put this first term in the first part of the box, 3x to the second, and the last term in the last box. And then we rewrite negative 2x as negative 5x and positive 3x. And these can go in either one of these two boxes. And now we want to think of two numbers that multiply and give us 3x squared. And we know we're going to have an x and an x to give us x squared. And we're going to need a 3 and a 1 to give us 3x squared. Well, I don't want to put the 3 on this side because I'm not going to be able to get negative 5x with my 3. So if I put the 3 up here And this is where it didn't matter if the 5 and the 3 were switched around, because then the x and the 3x would be switched. So now we just look at the top two numbers. We got 3x times x gives us 3x squared, and what times x gives us a negative 5x? And negative 5 is going to be our term there. And then what times 3x gives us 3x? Well, just 1 times 3x gives us 3x. And then just verify that this last box worked out. 1 times negative 5 gives us negative 5. So these two terms here now are our answers. We have x plus 1 times 3x minus 5. And if you multiply that out, 3x squared minus 5x plus 3x minus 5. And let's switch the color around and make it fun. Same thing with this one. Let's make a box. And we're going to put 5x squared here and 12 here. And we want two numbers that multiply and give us 5 times 12, which is 60. It's going to be plus and plus, so that's going to make our final answer is going to be plus and plus. And you can work these out a lot of times. I know I'm going to have a 5x and a single x, and I know it's going to be plus and plus. So you can kind of, it's not really guessing, it's deducing what terms can work out to multiply and give us 12 at the end. But let's work it through with the box method. It's got to add up to 19. And just think of numbers that it's all got to be positive. So numbers that multiply and give us 60. 60 and 1. 20, whoops, I missed one there. 20 and 3. 30 and 2. And we want numbers that are going to add up to 19. 15 and 4. And there we go, there's 19. And we could keep going 12 and 5. But they're positive and positive, so we got 15 and positive 4. And we're rewriting that 19x with 15x and 4x. And now I want two numbers that multiply and give me 5x squared. So I'll put the answer in green here. 5x and x. Now if I put the 5 up here, that's not going to work, because when I want to get to 4x, the 5x is not going to work. But 5 will go into 15. So I'm going to put 3. So 5x times x gives me 5x squared. Work across the top here. 5x times 3 gives me 15x. And x times what gives me 4x? Well, I gotta have to have a 4. And there should be our answer. Double check. 4 times 3 is 12. So there's our final answer. 5x plus 4 and x plus 3. All right, moving right along. So graphing, I'll do one of these with the calculator. Now they're going to look similar. For the calculator, what you do, and I think I already put this one in there, you hit the y equals button. 5 divided by x plus 2, and make sure that x plus 2 is in parentheses, and minus 4 at the end. And I have some xy, so I'll use the table function and get some points here. But before I do anything, I'm going to put the vertical asymptote in. So negative x equals negative 2 is my vertical asymptote, and then my horizontal is right here. Y equals negative 4. That's a horizontal line, and I'll put this I'll kind of do it dotted and narrow, and let's go green. So y equals negative 4 is a dotted line right here, and x equals negative 2, it's a dotted line right there. And let's go back to my mouse, and if I have my calculator here, I want to plot some points, and I already know the graph's going to be right up here and right down here, but just to make sure we got a couple of points, let's put in 0, -1, and I'll put in 4, and you can see 0, -1.5, -1, +1, and I put in a 4. I'm at -3.1. So at +1, 2, 3, 4, -3. See, I'm already below the line, and we're going to get really close to the line, but not quite hit. And then it's going to go, and it's never going to go. And you can put in a big number here if you want to just verify that estimate. If I put in a number like 100, way out at 100, I'm at -3.9, not quite to -4. And on the negative side, if I go past the horizontal or past the vertical asymptote, like -3, and let's go -5 and -8. And -3 is -9, and I should have filled this in, but I didn't. -3 is -9, so we're way down here. -5, we're right about here, and then we're going to start working our way up this way. And how steep and how close it gets to this middle part, that's where this 5 changes it. And remember, if that 5 is a negative, this gets flipped over. So this curve is down here, and this curve is over here. That's pretty straightforward. I know my graphs aren't perfect, but they are going to always have 2 parts to it, and there's going to be a vertical and a horizontal asymptote. If you ever want to know what the range is all real numbers, except y can't be -4. The domain's all real numbers, except x cannot equal -2. Domain is whatever x can be, and range whatever y can be. This one, the vertical is a little tricky because there's, well, actually both of them are a little tricky. +0, the vertical is whatever makes denominator equal to 0, so x equals 1, or you can put 2x minus 2 equals 0. And if you solve that, you add 2 and then divide by 2, and x is going to equal 1. So once again, I put my line in there. X equals 1 is that. And the horizontal, we're not adding anything extra. So it's just y equals 0, which is the x-axis. So that's the same line. And just in order to save some time, I'm not going to plot points, but it's going to look like this. And if I think of a number like x equals 0, that's going to be 5 over -2, which is -2.5. So right there is 1 point. So you can see I just quickly doing the graph, I was pretty close. If I put the number, well, what would be a good number? If this came out to be 5, so if this came out to be 7, x equals 3.5, 4.5. That's hard to kind of think of good numbers here. At the number 1/2, we're going to have 5 over -1, -5. So we're right down here. But there's what our graphs are going to look like. And once again, if you put that in the calculator, and you can go in the second table and get some points to fill out this grid. All right, and I just want to make this a little bit quicker. Now simplifying, now here it gives you a lot of practice with the factoring. 2 numbers that multiply and give you 20. add up to 9, so x plus 4 times x plus 5, and factor the denominator. Two numbers that multiply and give you negative 8, x plus 4 times x minus 2. And then we can get rid of our, well, I need to do the dotted line, get rid of our x plus 4s. So x can't equal negative 4 because we'd be dividing by 0, and x can't equal 2. But it does simplify down into x plus 5 over x plus 2. And you don't need to have those in parentheses. It's assumed they're in parentheses. But just keep in mind that these are, each parentheses, x plus 4 is a factor. It's a single term. So there's no crossing off x squared. So that's doesn't work out. And if you put in numbers for x, you can tell it doesn't work. But if you factor it, there's both of these have an x plus 4 in it. Okay, now this one, this is a little bit tricky because we have a 3 as a common factor. 3 times x squared minus x minus 2, and the bottom factors into difference of squares, x plus 2, x minus 2. And I'm going to just switch colors so I don't have to write that again. The top is going to be 3, and I'm going to try to write a little smaller. Two numbers that multiply and give me negative 2. Well, x minus 2 and x plus 1, because it's a negative x. Two numbers that multiply and give me negative 2 and add up and give me negative 1. Now, if we would have just factored this with the box method, we would have got 3x plus 3 times x minus 2, or we would have got 3x minus 6 times x plus 1. But once we factor this 3 out, it's a little easier factoring. And then we have an x minus 2 on the bottom and an x minus 2 on the top. So we have 3 times x plus 1 all over x plus 2. Some people have a harder time with this. Some people have a harder time with the kind of problem I just did. These are easier once you get used to them, I think. There's 3 x's on the top. X times x times x is x to the third, and there's x on the bottom. So I can cancel that x and take that third and make it a squared. So that gets rid of one of the x's. There's a y on the bottom, y on the top. 16 and 4 factors down into 4. So I end up with 4x to the second, especially with a big mouse. It's kind of hard to see, but everything canceled off the bottom. And there's my final answer. Multiplying, so this is just the same as the problems up above. It's just that we have more terms. Two numbers that multiply negative 10, x minus 5, x plus 2, and everything's getting multiplied together, so we have an x plus 6. And we'll be able to get rid of quite a bit of stuff here. We have an x plus 6, so we can see we can get rid of that. And if you can do this, then you're sitting in good shape. And then two numbers that multiply and give me 25 positive, but add up to negative 10. So x minus 5, x minus 5. And I know I'm doing that pretty quickly. That's the puzzle part of it, is to figure out what two numbers multiply and give you 25 positive and add up to negative 10. So x minus 5, so we can get rid of the x minus 5, one of them. We can get rid of an x plus 6. And our final answer is x plus 2 over x minus 5. All right. We're getting there. And I think, is this the last page? Oh yeah, there's an answer key. Okay, divided works pretty much the same. It's just that you got to flip the second term. So we have 16 x to the third y all over y to the second. And then that same thing, then I'll multiply instead of divide, and then the y goes on the top. And then 8x squared on the bottom. And I'll pick a different color, and we'll go blue. So I have y to the second. There's two y's on the bottom, and that y is y to the second. I have x to the second on the bottom and an x to the third on the top. So that 3 becomes a 1, which is just x. I put it as a 1. And then I have an 8, which goes away, and the 16 becomes a 2. 16 over 8 is 2. So we got rid of a lot. What's left over is 2x. There's no y's because we have y to the second. I had to flip that. And so the y's are gone. That x to the third became x. And that's all there is, 2x. And this one looks fun. Then I can see this x plus 2 is going to go on the top, and there's an x plus 2 on the bottom, so those are going to get canceled off. Two numbers that multiply and give me 6. Add up to 5, x plus 2. Well, there's another x plus 2. X plus 3. And we have an x plus 2 on the bottom. And divided, so we're going to do times, and that x plus 2 goes on the top. And this term goes on the bottom, multiplies to be negative 20. Negative 4 times 5, but that doesn't work. How about negative 10 and a positive 2? X plus 2, another x plus 2, and an x minus 10. So this goes pretty smooth, but if you do make a mistake in factoring, of course, that kind of messes things up. Switch it over to purple, and my x plus 2 gets canceled, another x plus 2 gets canceled, and we're left over with x plus 3 over x minus 10. And I'm just moving this over a little bit. I'm going to delete these because that kind of got messed up. I'm just making a little room over here on the right. This one looks messy, but it's really not as complicated as it looks. So the first thing to notice is that the terms x minus 5 and x minus 6 are just single terms, but they're really kind of just over 1. So that's no big deal. So this x minus 5 is just x minus 5. I'm just going to make it all one big multiplication problem. X minus 5, and then I'm going to times. So only this middle term gets switched around. So the x squared plus 7x plus 12 goes on the top. Two numbers that multiply and give me 12. So x plus 4, x plus 3. And then now it's multiply. So then times x minus 6. And then on the bottom there's just a 1 and a 1. And then here, this gets flipped over. Two numbers that multiply and give me 30. Add up to negative 11. Positive 30. So x minus 6, negative times a negative is a positive. X minus 6, x minus 5, which is nice. You might want to take note of that because that's kind of how the test is going to work. I think those two numbers end up being those two end numbers, so it makes it for easy factoring. Let's go with green and cross off common factors. X minus 5 can go away, x minus 6 can go away, and our final answer is x plus 4, x plus 3. And there's actually a lot of terms here. If it was, they would never do this on a test, but if any number that won't work for this, would be anything that makes the denominator equal to 0. So positive 6 and positive 5, x equals 6 or 5, will make it so you're dividing by 0. But also, just within this term right here, you can't divide by 0, so it can't be negative 4 or negative 3. That'll make it so you're dividing by 0 initially. So all of these kind of, there's kind of a few terms that you can't use. But anyway, that's, for this, we don't have to say what they called extraneous solutions. This one we don't have to worry about. It's just x plus 4, x plus 3. When we get in the second part of Chapter 9, we'll get into that. And just before I end the video here, I'm just going to scroll through just so you can pause it, and we can verify my answers. That looks right. Here's some points that I actually did plot. So if you want to pause the video and get some points there. Looks like I initially put my asymptote at 1 when I was making up that key. And x plus 5 over x minus 2, 3 times x plus 1 over x plus 2. 4x squared y. A little hard to read. X plus 3, x plus 4. X plus 3 over x minus 10. Is that what I got? X plus 3 over x minus 10. Good. So there is the solutions. Hopefully I didn't scroll it around too much. And have a good one. Talk to you later. Bye.